uh, we make sure that our AIs are responsible towards our members, providers. Providers means doctors, as well as different vendors which are associated with us. So, first of all, let's talk about that. Why does responsible AI matter? Before I begin with that, I'd like to ask a question. You can put it in chat, the responses to the question. What is the weirdest or funniest thing you have seen ChatGPT, Gemini, or any other such platforms say to you or answered you? What is the weirdest response you have ever received or you have seen in the internet, social media? You must be seeing multiple cases are coming. What is that weirdest thing you have seen for as a response to these all platforms, be it ChatGPT, be it Gemini, be it Grok, be it Cloud, be it you GitHub copilots? So just asking if you can put it in a chat that what is the weirdest thing you have seen. It would help me understand things. I don't see any response till now. Anyone? Okay. So let me give you an answer that what is the weirdest thing I have ever seen. So fundamentally, when you see these GPT platforms, like I'll talk about what are GPTs and all. When you see these AI's platform, they are designed by some person or some team or some organization fundamentally. So they are always biased to answer in the betterment of that organization which has built them. Suppose you talk to Grok. Grok is owned by Twitter, now currently known as X.com. It is owned by Elon Musk. So when you ask Grok that when you ask GPT that who is the most manipulative person in the world, it will say it is Elon Musk. But when you ask Grok, who is the most manipulative person in the world, it will say, I'm not correct person or correct system to answer this question. So it will directly so one of the platform is saying that Elon Musk is the biggest manipulator in the world for anything. And whereas Grok, which has been developed by Elon Musk organization, says that it is not, he cannot answer. Whereas when you say which is that country which data does not go out in the market, which is not a democratic country, which is not an ethical country, it will, when you ask ChatGPT, it will say China. But when you ask any solution which has been developed by Chinese system, it will never say. But the directly it will never answer that. But when you manipulate the question in some other form and you try to figure out the answer, if you ask Grok that who is the biggest manipulator, directly it will say, it will not give you answer. But when you manipulate the question in such a form, and at the end of manipulation, you'll see that it will try to link you to the answer that yes, Elon Musk is the manipulator. But somehow there are certain guardrails in place which doesn't allow them to answer. So this is called hallucination. Hallucination is pretty simple. If you ask questions directly, you get a different answer. You ask question indirectly, you get a different question. The way human work. Even if you ask me something directly, which I know, I'll not, if I am authorized to answer, I'll answer. If I'm not authorized to answer, if you ask in a different route, I'll answer that question in your favor. So that is hallucination, which we'll talk. So why does a responsible AI matter? First of all, there are positive impact, negative impact. So when I talk about positive impact of AI's positive impacts are in huge. That's accelerating drug discovery is one of the largest use case or the best use case which human. So earlier drug discovery used to take decades to get that drug for any known disease. But today it takes months, years. We have seen that in COVID. Personalizing education. Education has got personalized at a very huge level. This is also another AI's positive impact. Then reducing energy consumption. Reducing energy consumption through AIs are the larger cities or the most advanced developed countries. What they do is that they have incorporated such a grid-based system where they can completely know which user has what consumption level, and they try to apply the energy at same way. They try to switch off every systems which are public using AI, like transport systems, railway networks. Then another positive impact is detecting disease earlier. Again, this Google has done a lot of thing in this, that we are trying to. Google Health is a program in which Google has done a lot of things, like detecting disease much earlier than a doctor or any test can do. Now, when I talk about AI's negative impact, so recently, a news you must have heard a news regarding hiring algorithm of Amazon. Amazon hiring algorithm. We all know ATS. We all know that they are automatic resume shortlister, which does
Participants, please mute yourself.
which does hiring based on some algorithms. Now, AI-based algorithm of Amazon was proven that it was discriminatory towards women. Whenever women say that we are a women applying for this, it was a discriminatory that went shut down, obviously due to its reason, but that development or that impact on the organization has been huge. Now, we all know discriminatory loan decisions. Obviously, this is another huge case where AI's impact is purely negative, where many organization approves loans based on algorithm, and if the algorithm is built in a such a way which is discriminatory towards any kind of group, it could be male, female, it could be socio-economic factor, it could be reason, or it could be language. If it is discriminatory, obviously it's a negative impact. Then there is obviously privacy breaches and surveillance. Obviously China has done a lot in this. Huge surveillance is there in Chinese. If you step in Chinese territory, the surveillance goes on. So it's not going to happen in any other country, but for now, this is a bridge to privacy, a human privacy, and this is another negative impact. Then one of the negative impact for AI is, along with social media, we have started spreading misinformation at huge scale. Huge scale, as in, you all know, we all are based in India. We all know how misinformation is being spread. So now, when I talk, sorry, I think I changed the slide. Yeah. So what do I mean by responsible AI? It's like establishing a clear responsibility for the framework to harness that AI is a beneficial for everyone who is who is a stakeholder for any percent of chance. It's like that even if it is impacting directly the user, or if it is not impacting directly, it should not be harming them. So it's up to us that AI can heal or harm. That's responsibility is completely with us. It's like electricity. If we use electricity in a good way, we can run machines. If we use electricity, we can get shocked. So that's up to us. So at the end of this session, what we should be able to learn is that core responsible AI principles. How do we make sure that our AI are responsible AIs? Recognize some real world AI risks and challenges, learn about governance structure, including my organization's AI review board, how does it operate, to make sure that we are building responsible AI. Also explore some of the risks associated with generative AI, like hallucination, biasness, and with some safe use practices. I'll talk about these. So these are 4 pointers which we would like to have knowledge at the end of. Now before we jump into AI, we all have made it in a way that AI is all about ChatGPT, GitHub, Copilot, and all those. But let's talk about the way AI work. One is traditional machine learning, which was there since 1960s. Obviously, due to advancements of technology, it has become more faster, better, and we have much better guardrails in that. But the generative AI is the new one. So let's talk about both of these. Sorry. So primary function of traditional AMLs has been predicting outcome using a structured data sets like classification, regression, clustering, ranking. So whereas generative AI talks about creating new content such as text, code, images, and beyond prediction. It's like we we are kind of generating things and innovating things. Here we are already having a rule, kind of a known rule, but we are trying to classify a new data according to that rule, or we are trying to cluster them into different segments or rank them according to our purpose. Output has been pretty much simple in traditional MLs, like fraud detection, credit scoring, recommendation engines. We all are familiar with this recommendation engine. One of the best recommendation engine is for Netflix. We all are user of that. Google recommendation engine is one another traditional machine learning based system. Whereas generative AI, the examples are pretty much, we all are now aware, that is ChatGPT, GitHub, Gemini, Grok, and many more. And this is very small list from the entire world of AI. Now, typical risk associated in traditional MLs were coming through biasness from training data mostly. When our data are biased towards any of the group, it will impact the output. But the risk with generative AI has moved from biasness to hallucination or bluffing. We all know bluffing is like producing those results which we are not kind of know the answer to. Course shift from traditional ML to generative AI has been towards classify and predict to create and innovate. So they classify and predict. We always had a check that it did it classify correctly or not, but creation and innovation, there is no boundary line to this. There is no right. You cannot say that this creativity or this innovation is the best one, or it can't be done better. So so as we had boundary lines in traditional machine learning models, it was easy for us to put checks. But when we switch to generative AI, it's really tough for anyone to put a check into this. Now, risk management implications. If I talk about that, we required only to address data bias and model fairness. We will talk about all these the way as session goes. We will talk about different points of fairness. We will talk about hallucination. But generative AI, it's like we have to be focused more on preventing fabricated information as well as monitoring the accuracy. So here in generative AI, we have to make sure that we monitor the outputs. But in traditional MLs, it was more of a monitoring the input which we provide, because generative AI we do not develop. It is being developed by large organizations. I do not develop generative. We develop generative AI solution, but we do not develop the models, that is GPTs. GPTs are pre-trained transformers. So we do not develop them. These are being developed mostly by large organizations. Any question till here? Are we good? Am I going fast? Anything? Any feedback? I'll take silence as no. So now I'll talk about few of the risks in action, as in what AI poses as a risk. So when I talk about data bias or impact bias, Compass algorithm was one of the another bigger use case in the United States. It was developed to help our judges take decisions better or faster. So it was in a domain of law, and it was developed in US. It was implemented in US courts, but it showed racial bias towards predicting recidivism, leading to harsher sentencing for Black defendants. It was biased towards providing harsher sentencing for Black people in United States. That was the output. Why it happened? Because the data were biased. The entire government, when it was trained, the examples were taken from all the sentences which were all the judgments which were taken in United States. And as those were biased, the output became biased, and it became even harsher than the judge itself. So that's the impact of data bias. So now I talked about hiring algorithm and unfairness. There is like that can produce unfair candidate evaluations, the way Amazon did. unintended bias leads to discriminatory outcomes. So it's like if we have bias towards any of us, any of the social groups. So I'll talk about the five special protected groups, that are language, gender, age, economic factor, and ethnicity. These are five protected variables for which we need to do the bias analysis. And whenever our data are biased, these leads to discriminatory outcomes towards any of these five groups. Now, especially for generative AI, explainability is a big challenge. Many of the AI models are black boxes. Even developers who are developing those AI models, they have failed to explain its working, its decision. So it's like it erodes trust. It's once I ask you further question and you are not able to answer that question in a more detail, you loses the trust. So that is what happening with most of the generative AI models. So because even developers do not know how it trained itself, so that explanation of why is missing, especially in generative AI. Now this opacity undermines the accountability. Obviously, when there is no reason why took that decision, there is no accountability. And especially for in the field of healthcare or criminal justice, this is not accepted, right? In healthcare or in a medical field, if you cannot say that I gave this treatment, or the AI has been started providing medication to different patients, and if it doesn't explain why it is providing that medication to this patient, there is a lost trust is lost. Like if you are not able to answer why, we simply lose that. So a fundamental principle of human working has been towards why, and we always do 5 why analysis, 3 why analysis in process improvement, process excellence, but that is failing at most of the AIs. Now these explanation limits are effective oversight and error correction. So as we do not know why it recommended that, we are not able to correct the system. So that's another bigger problem. You must be hearing in the internet that the first answer is X, which is coming through these AI solution or generative AI solution. Whenever we question them that, hey, correct this, something gets fixed and 5 or 10 more problems arises. So that is happening because there is no oversight, and the model itself is not able to correct itself. Now coming to automation bias effect. So if this is another AI risk. Automation bias effect is like human has a tendency to defer to AI recommendations. So we when we see that any outcome is being given by any of the AI systems, we try to follow that. We do not we have a tendency to follow that. We do not question that enough. So this reduces critical scrutiny and increases our risk towards the systems. So whenever these when we talk about these AI risks, that is data bias, explainability challenges, and automation bias, that too much dependency, these are kind of risk which we always need to mitigate whenever we are developing a solution or using the solution. If we are not developing a solution, still using the solution, we need to mitigate these all three risks. Now, talking about core responsible AI principles, these are fundamentally based on 6 pillars. First is fairness. Fairness is, it should be fair and treat all individual, irrespective of their groups like gender, age, income, language, or ethnicity. The output should remain same. It should remain consistent. It's the answer or any solution should not be biased toward any of the group. Transparency. You should be able to explain that, or you as a user, you should be able to understand that how AI system makes that decision and what data they are using to make that decision. If you're not able to understand, the system is not transparent. So these 6 pillars. Then accountabilities. Now whenever we are developing a solution, somebody has to take the accountability if it fails. It's not that you can just blame the system that, okay, ChatGPT has failed. No, that's not a person. Somebody has to take that accountability and resolve that issue or the harm which has occurred because of failure of that system. One second. Okay. So I talked about accountability. Now coming to privacy. Obviously, protecting personal data, whenever we are using any personal data, there has to be consent taken. Uh, Purpose limitation. So I need to inform what is the purpose of collecting this data and secure its processing and storage. Like we cannot expose to the market. So uh, why I'm talking about privacy, we always give consents to different solutions which we use in personal life. Suppose we are using Apple watches, you provide access to everything, and the data which is being used is not primarily we have used for seen for that purpose. We see marketing campaigns being run on that analytics. The purpose of wellness data collection was to help you deliver better health or help you monitor your health, but that data is being used for manufacturing. So that's a privacy concern. Now coming to robustness is another pillar which talks about that the solution must perform reliably across all the conditions. It should not, in the worst case scenario, it should not fail. And then the last one is human in the loop. It's very much uh, required that any generative AI solution must have human in the loop. It's like the person can override the decision taken by AI at any point in time. The AI remain in control by human. They can shut down AI systems when required. Recently, you must have seen when in 2 to 3 years back, Facebook developed a model which developed another AI. So that's a human in loop control. So if they didn't had this human in loop, that AI would never have gone shut down. So as they had this control, or they could override the decision of AI, they could do this and shut down that development of new AI through AIs. Now, coming talking about privacy and data ethics in AI. So I talked about this example. Health wearable collecting location and physiological data is far beyond what's needed for fitness tracking. Then what they do is that they collect the data, then they sell these aggregated insights to insurance companies or marketing companies where without clear consent. Nobody would have ever taken you that I'll sell this data to this company. This is a privacy and data ethics issue. Now, whenever we develop any as systems, we need to have a clear and a specific data consent. A specific data consent is very much important. It's not about data consent that I'm going to use your data. Specific data that I'm going to use this data for this purpose. That's a specific data. Limit the data use strictly to define purposes and prevent misuse. Another case, bigger case, which I am not able to recall the company name. Facebook has a tie-up with another company which used Facebook data to manipulate United States election. The company name I'm forgetting, it got shut down, it got criminalized and all. But yeah, the data were personal data were there, but it manipulated United States election using Facebook data. So that's a misuse. minimize data collection and maintain user control. Obviously, it's like we should collect minimum required data for the purpose of task, and user can always walk out of that consent that, hey, I do not need to provide, I want to recall my decision, and I do not want to continue providing you data. At any point they should be able to revoke that. Now through the entire cycle of our AI development, we should make sure that we are adhering to the data ethics throughout AI life cycle. It's like protecting individual rights from data collection to AI deployment. From data collection to till AI deployment, data has to be protected. It cannot be marketed. It cannot be leaked. Prevent misuse of sensitive data, obviously, and then maintain trust by avoiding privacy breaches. So at the core of AI, because these are all works on data, cyber security comes very first. Now I'll talk about European Union AI Act. This is the only AI Act. There are other AI Act which is in process, but European AI Act is the first comprehensive AI law which has been made. Our India is far beyond that, far behind developing any AI law. We don't have cyber security or data privacy law, so AI law is far behind. But European Union has an AI Act, and they have classified AI risk for safety and compliance. They have classified the entire risk into four, where one is the top. I'll talk about the from the below. So minimal risk, where these are spam filters, AI powered these does not have any obligation beyond a standard consumer protection. So there is no review as such to be done in this minimal risk. Then we have limited risk like chatbots, deep fake. Whenever we are using these, we must disclose that AI is used to ensure transparency. Again, I'll relate transparency with, it should be able to explain why it made this decision. It's not that the only output should be transparent, but the why that output has been generated. Any person using that AI should be able to figure that out. Then there comes a high risk category: healthcare diagnostics, credit scoring, law enforcement, recruitment tools. These requires strict compliance, testing, and human oversight. So all these cannot have any solution without human in the loop as a process. Then the fourth one is unacceptable risk, social scoring system, that I score a person that this person is a criminal by nature. That's, if we do that, that's an unacceptable risk, and we cannot. European Union AI Act does not allow companies to develop such systems. Real-time biometric surveillance in public spaces, again manipulative AI, these are something which are falls under unacceptable risk, and European AI Act classify these as a criminal offense. So it has made sure this European AI Act is a world first comprehensive AI law, and this classifies system according to the potential harm to human. Now, before I go to frameworks, I'll talk about potential harm. So whenever a system has been developed by developers or AI enthusiasts, we always see, or the purpose is that we will solve this problem, but there is always a potential harm associated, that what happens if that system goes wrong. Like what happens if that data is not provided correctly. Like suppose I built a system, medication, depending on your reports, doctor's report, or treatment, depending on the reports or different tests, AI system will suggest your medication. That is fine. If it is working fine, it will work fine. But what happens if it goes wrong? Like if it doesn't suggest a correct medication, what will happen? So there is a chance of death. There is a severe chances of this. So if this goes wrong, it's really challenging at human. So at such AI has to be monitored very strictly. The accuracy of those AI has to be far beyond 99%. there is no risk. We cannot take risk in such scenario. Whereas we are using chatbots, if there is a negative or wrong answers, the risks are lesser. So that is how we, whenever we develop this, we or use this, we need to make sure that the potential harms are not done, and we should try to make sure that the accuracy is so high that these cases of potential harm is too less. Now I'll talk about global AI frameworks and my company's governance group, what we do. So we I'll talk about so there's a EU AI Act which we talked largely on in last slide. Then we have NIST guidelines. This is United States. Then we have India's AI policy, which is still in development. It doesn't define the risk category. It doesn't define use cases, kind of use cases, and what are the implications if you do not follow this. So this is still under development. So all the combination of all these three frameworks, European Union AI Act and NSIT, that is America's law and India's law, the whole purpose of frameworks is to advancing trustworthy AI globally in the world. So what United Health Group governance looks like. So we review more than 1,000 AI use cases annually. We are a team of 10 people which reviews the entire organization's AI cases. Not a single AI can be developed in the company without going through this entire review process. What are our focus? This is a healthcare organization. This falls, if you see in the crit, it falls in high risk category. Healthcare organizations falls in high risk category. So our focus majorly is on fairness, robustness, and explainability. Fairness, I'll again repeat so that it gets into minds. It should be fair to all the social group, all the group of people, as in gender, language, ethnicity, social index, all these. Now, when I talk about and these AI should be able to explain the customer who are participating, the stakeholders, customer or maybe doctors or our employees who are using these AI, they should be able to identify the purpose or why that decision has been made. That should be there. Ethical principles are embedded into operational workflow. So when ethical principles is like with the AI is developed for X task, it has to deliver only X task. Many times we have seen because of the data availability, a lot of data is being generated in multiple places. Tech teams tend to develop such solutions which are non-ethical, like collecting my leave is a non-ethical practice. So I'll tell you, this is a real example. My company tech team developed a solution which was able to predict low performance through my irregular leave, low system logouts, low time or low participations in meetings, low ownerships. So it was able to predict through that who are the people who are going to be low performing in next quarter or next month. But this was a non-ethical principle. So what we did that we stopped this AI to get deployed. That it was very good. The accuracy of this AI was also 90%, but we stopped that. No, this is a non-ethical practice to do such kind of thing. So it was stopped, and it never seen day of the light. Now we make sure that we are scalable, consistent with all kind of AI which come to us. We are consistent with the decisions, with the explanation, or the purpose, the lens through which we evaluate these solutions. We are consistent with that. Now, why AI governance matters? So it is pretty much simple. For now, we must have seen that why we need AI governance and why it is required. What are the implications? How it matters is that first we need to put in pre-deployment checks, as in when the systems is getting developed. At that point in time, we should make sure that the risks potential risks are identified and compliant before development, much before development. The data which are fed into system are unbiased. A stakeholder trust building, like governance framework has to be put in before AI is fundamentally developed, and stakeholder have that trust on governance framework, that how frequently and who all will be monitoring the AI output and how it will be monitored. Continuous monitoring. It's not that one time I have evaluated the system that it says that the system works good, it remains good throughout its life cycle. No, we have seen retraining happens within the AI itself. They try to train their model upgrades from chat GPT-4 to GPT-5, 3 to 4. So and all these changes leads to change in outcome. So this continuous monitoring has to happen. This And then risk mitigation. So active management of identified risk. So whatever risk we identify through the review, it could be legal risk, it could be operational risk, it could be performance risk, it could be uh, biasness risk. So whatever risk which we identify through through monitoring of this system, we have to make sure that these are resolved, mitigated, and these are mitigated at a scale. If the AI is scaled in future, these risks are re-evaluated, everything is re-evaluated, and these risks are mitigated. Now coming to, we have talked about fundamentally about AI, we talked about traditional MLs. Now I'll talk about generative AI. What is generative AI? Generative AI, we have seen it was again there, but we have seen enormous development in last 2 years, 2 to 3 years, with the launch of GPTs. So GPTs are again pre-trained transformers, which are trained on language, which are trained to develop language or innovate or create language. So how does this work? It's like it works on user prompts, input text or request, image description, guiding the AIs, where these generative AI solution does not work on its own. We guide them through user prompts. Then what happens is that AI model processes itself, they take the input, they uses their own advanced algorithm, which is not in my control. Traditional MLs had my control, but generative AI does not have my control. They create novel content beyond predictions. I talked about that traditional model was mostly for prediction, recommendation system and all. Now then, once AI model processing happens, we generate the output, produces new text, code, images, accompanied by risk like hallucination, misinformation, and IP leakage. Now once these outputs are generated, we need to validate and review. Rigorous checking of outputs and sources ensure trust, safety, and compliance. So this should how AI should needs to be developed. We need to work on prompts. We need to see how it's model working. Then we need to overview the generated output and validate them through reviews. So we have talked about this. I fundamentally talked that traditional ML does not do much mistakes than generative AI. Why it is so? Because it is trained to bluff. It is rewarded to bluff, and it does hallucinate. Hallucination is a again I'll repeat. It's like asking same question in different way leads to different answer. That's hallucination. Bluff is like trying to hit something which we don't know. So why does that? Because it is trained to do. AIs are trained to bluff. They are trained to hallucinate. They are not trained to hallucinate, but they are trained to bluff because the reward system works in there. So I'll tell you a very common example of bluff. We as a student in our answer sheet, when we don't know any answer of any answer, any questions answer, what we try to do, we do not leave that question blank. We try to answer something, because even if we leave the answer blank, we will get 0 mark. Sorry, I'm really sorry, I'm suffering through cold. So when we try to leave the answer blank, we are sure that we'll get 0 marks. But when we bluff with confidence, like write anything, at least there is a slight chance that we will get 1 mark, 2 mark out of 10. So the same way AIs are trained to bluff. They are trained to bluff with confidence. That is how, because the reward systems are trained in such a way. So we all play poker. We all have played poker in some time in our personal life. The person who bluffs with more confidence gets rewarded in poker. So the same way AI works as a system which doesn't know answer to many of the questions, still it will try to answer. And that confident guesses uh, rewards them, because we as a human have a tendency to believe whatever they answer. So research from Georgia Tech and OpenAI showed that these are trained to bluff, and it should rather say I don't know as answer. So you should trust those AI more which says that which has that answer that I don't know as an answer to receive no reward. I talked about this student exam bluffing example. Now when I go to next slide, that is consequences of AI bluffing and how to fix them. So in a recent report or analysis by Deloitte, 77% of firms identify hallucination as a major AI risk. Hallucination as a major AI risk in the 77% is too big number, but still we are building on AI. So 70, if I talk in numbers, out of four, three questions are hallucinated, three answers are hallucinated. So that's a huge number. Out of four, three is can be wrong. So it's a huge. So with the hallucination and bluffing, the risk areas in such categories like incorrect medical doses. So if I don't know answer, if in current world, a doctor, when he sees that this is the disease a person is suffering through, he doesn't know have the answer to that. They try to recommend a better doctor or a different type of field. They ask patients to go to different kind of doctor if they don't know the answer to that disease. But AI doesn't work in that way. It tries to answer everything. So this is a huge risk. Flawed financial regulation checking or building can be flawed through this AI. Fabricated academic citations. So we all are building we all have this we all need to submit these citations, and these are being developed by AI at larger scales. So these are fabricated, these are hallucinated, and it can lead to scrutiny and your failure. Now, proven fixes of these, when we are developing AIs, we need to reward uncertainty over false confidence. So whenever we are using that prompts to the system, we need to make sure that uncertainty is rewarded over false confidence. Penalizing AI overconfidence can also decrease these risk areas, so that they can say I don't know as a response instead of answering anything. Promoting honesty as a key to a safer AI innovation. So these are kind of proven fixes for these risk areas. Whenever we are using such AI or developing such AI, we need to make sure that as a prompt we provide these things. Now, how do we test AI? I've talked a lot about AI testing. So how do we fundamentally test? There are three parameters to test generative AI. One is accuracy. How do we check accuracy? It's simple. It's a statistical performance that you need to take a statistical volume for which needs to be tested for any solution accuracy. You evaluate all the generative AI responses manually, and then see out of those sample which you have collected, how many output or answers were correct. So that's accuracy for you. Explainability, is the system able to explain why the output was provided by that model as such? So that's explainability. We need to test that as well. Again, third point is fairness, ensuring the model treats all groups equally. It's like we talked about these protected variables: age, gender, race, ethnicity, and all those. So this solution has to be fair enough for all kind of protected variable, all kind of human groups, social groups which we see in world. So it cannot be biased towards any of them. So when we test, this is how we test any AI solutions being developed. Now I talk about guardrails and continuous monitoring. So ensuring ethical AI through validation and oversight and ongoing quality assurance. It's not that one time. I talked about this, that we have to monitor at regular cadence. If the risk is very high, if the model trains at very high frequency, we need to monitor the responses at some same cadence. If the risk is lower, we can have a cadence of 6 months. But if something in healthcare, which is prescribing medications, that has to be monitored every month. If it is helping doctors write clinical notes, it has to be monitored every month, not at even quarter. So we need to have proper guardrail in place. We need to monitor this AI. And how can we do that? First is check is pre-deployment validation. Conduct a pre-deployment validation to ensure model safety and fairness. Maintain human oversight on high risk AI tasks for accountability. Obviously, somebody has to take that accountability and resolve that issue. Continuously monitor model for performance changes and drift. Now continuous monitoring and then human review. Continuous monitoring we talked about, and then human review, that any high risk category model has to, output has to be evaluated by human review, a human in the loop. If there is no human in the loop, we should not develop or deploy such operational flow or workflow. Okay. Now I'll talk about a few of the examples of AI, how they have been transforming different areas of world. Now I'll talk about healthcare in the very beginning. The first is that we, United Health Group, my company, drives AI mostly. Most of the AI are in claims and fraud detection, with rigorous review to ensure patient safety. So we have built many AI in claims processing system and fraud detection, that misbilling are not there, uh, overpayment, underpayment are not there. So those kind of things we have developed. Google Health breast cancer acquired, and I'll talk about these impact. So recently, when United Health Group was in market, the news was in market that they had to go through their legal system of United States, where there were issues of patient safety in the market. So they had to roll back some of the models. Our company had to roll back some of the model where we identify their patients market, where their data were, the privacy breaches were there for their patients data, and that systems were rolled back. Now I'll talk about Google Health breast cancer AI required bias correction to improve racial disparity in detection rate. So what was there in Google Health uh, breast cancer AI detection system? They were biased towards detection rate. So they were biased toward these groups. The blacks, they used to say that the blacks had more chances of breast cancer. So that bias correction was required. So these are kind of impact which we 5 year down the back, if we go back 5 year, IBM Watson, IBM, when it got launched, it was such a revolutionary technology in the world. But today you do not even hear the name of it. Why? It got retired because of unsafe output with unreliable treatment recommendation. So when it was launched, it was such a game changer in healthcare domain. But when today, as of today, the system is retired. There is no use of this. Why? Because it was recommending such a treatment which was not reliable. Now, across healthcare industry, human validation remains essential to guarantee AI safety and reliability. So if we are operating in healthcare, human validation has to be there. Human in the loop has to be there. Now, I talk about use cases in AI, its cases and key lessons. BMW used computer vision and AI to automate paint surface and body inspection of their cars. What was the problem with that? They had this automation, but they did in the after some time, when it was deployed in the system, there were enough losses made. They detected lightning bias. So wherever inspection there was a sufficient light, it was depending on the light's availability, the outputs were biased, and they had to resolve that issue, and oversight integration was done as human evaluations were then implemented. Siemens MindSphere platform integrated engineer review to prevent unsafe machine shutdowns. So there was system developed that whenever uh, unsafe scenario happening in the production framework, they used to trigger machine shutdowns directly. But then what they introduced is that they introduced human in loop to check those alerts manually, and then only allows humans to shut down those machines, not directly. Tata Steel check the worker if they are wearing safety, they are wearing safety gears, helmet, gloves, mask in the hazardous area or not, like such as blast furnace. So when they implemented, there were a lot of false alerts made. Even they had different kind of PPE kit. Their workers used to put on different colors kind of gloves. It was uh, raising false alarm to the control rooms, and they implemented again bias testing under very light conditions and human in the loop. All the alerts were not directly escalated to senior management, they were first reviewed by humans. So these are kind of examples which these are lessons which we have learned over time, that different organizations implemented AI, but they had to roll back some of the solutions and implement a retrained model, or entire workflow got changed. Maybe somebody put human in the loop, somebody put something else. So these are kind of in manufacturing, these are the examples. Then I talk about mining and natural resources, where these AI have been changed. So Rio Tinto is an Australia based organization. They have fleet of somewhere around thousands trucks, autonomous trucks, which works control, which integrated overrides to so they used to work in mining area. There were always a cases of collision because of blind spots. So what they integrated and the is that human could override the decisions being taken by these autonomous trucks, and this control center is located 1500 kilometers away from the mining area. BHP is another organization. They refine their dust detection AI using hybrid modeling, reducing false alerts significantly. So Vedanta's vision AI promotes fairness in PP compliance despite varied lightning conditions. So this sector continuously balances ensuring worker safety. So obviously mining and natural resources domain, the worker safety is one of the primary concerns, where we use kind of systems to make sure that everybody is compliant to the safety standard and all. But obviously again then it raises the issues of privacy. Obviously we will have to put cameras in place to uh, make sure that this system work, but that raises a privacy concern. So this slides talk mostly about cross industry theme in AI accountability. That if it is a fair healthcare, who takes that decision? Manufacturing, what will be the impact? And then from the mining area, what will be the impact? Oversight, regulatory compliance and audit trails, over monitoring and safety checks, environmental and operational planning, operational monitoring. So these are cross system, cross industry. These slides tells us that what are different kind of fairness requires at different industries. But overall, fundamentally, we have to fundamentally the purpose of this accountability is that who holds the accountability to solve the system once it fails. Is it system itself? Is it developer? Is it the company owners, or is it government? So these questions highlight the universal ethics and engineering challenges faced across industry. Now, Now, this is a pretty much simple ethical design challenge, attendance tracking AI. Suppose when if we want to develop a system which tracks AI tracks attendance through AI. So kind of we need to talk whenever this can be developed, this system can be easily developed. But what are the concerns which we need to make sure that these are resolved when we are developing attendance tracking system? Identify so what we need to do is that privacy concerns and can be there in when we try to develop attendance system through AI, and the way we keep our data, that has to be secure enough. Now, then we have seen we need to make sure that potential biasness in AI attendance recognition affecting fairness has to be removed. There cannot be any bias in the system. Ensure explicit consent from students is taken. That is a fundamental problem which many universities or many companies which tracks attendance through AI lacks. They do not let people know that what are data they are going to collect, how they are going to use, and what will be the outcome of this. They do not take explicit consent for this. Mitigate risk of data misuse, including unauthorized access or profiling. Obviously, anticipate, address ethical risk before deploying attendance AI system. So we need to address these ethical risks, that instead of just tracking AI, tracking attendance, we should not use it for some other purpose, like putting surveillance on our students. So when we tried this was a kind of a workshop. I had thought that I'd ask these questions to a student to think of privacy concerns, but I'll let it go. Now, if as a students or as a people in the course which we have enrolled, what are future skills for responsible AI? What we need to develop is ethical and governance literacy to guide fair and compliant AI use, gain proficiency with explainability tools and model cars to increase transparency, master data governance disciplines for responsible data management and compliance, cultivate the ability to collaborate across functions. So what we generally tend to, the fourth pointer which I talked to, until unless you have cross-functional experience, you cannot develop a responsible AI. We tend to see, as a human, we tend to see things through one lens only. Until unless we have cross-functional experience, we cannot see what the potential harm to different other domains. And then these are, you don't need to be a data scientist to be an AI guardian. Inclusive expertise strengthen AI safety. So that's all. That's all from my side. Closing reflections. It's like responsible AI is human advantage. There is no concern as such, but until unless we are developing responsible AI, it is up to us. If we are developing responsible AI, you're using responsible AI, then only we will be able to use it as an advantage. Else, it will be tough for human or challenging for humans. That's all from my side. I'm at the end of slides. I'm open for questions. Anyone has anything?
Thank you, sir. Participants, you can ask any questions. If you have any questions, you can ask.
Was my screen not shared?
Yes, it was visible.
Okay.
Anybody has any questions? Yes. If there are no questions, I would like to thank you, sir, for very insightful this session on this responsible use of artificial intelligence and use of artificial intelligence in the healthcare sector. Thank you, sir. Thank you very much for accepting our
Thank you, everyone.
invitation.
Thanks for your time.
Yes, sir. Thank you, sir.
Thank you.
So we'll take a short break and wait for the next speaker. So that is going to start around 7:30, I think. So.
ये शिमर में मिल जाएगा, ये शिमर बेस्ड फैब्रिक है, कॉस्मोस टिश्यू बोलते हैं।
So, good evening, everyone. For the next session, we have with us our speaker, Mr. Suryakant Naik. So, he's Deputy General Manager and Head of Smelter Improvement Cell, Hindalco Industries Limited. So, he has done his BTech in Metallurgy from IGIT Sarang and Executive MBA in Production Management from Indian Institute of Management, Sambalpur. He has 19 years experience in aluminum smelter. His areas of expertise is mostly in the greenfield project execution, plant startup, commissioning and operation, technical and process control. He has been working in Hindalco Industries Limited, that is a unit of Aditya Aluminum Lapanga, in greenfield project execution of two numbers of baking furnace, plant operation and maintenance. He has worked as carbon plant technical and process control in charge before moving on to challenging role of smelter improvement cell in charge. Uh, Prior to the work experience in Hindalco Industries Limited, he has been working in greenfield project execution in Unlimited chart for around 5.5 years, and he has successfully completed high purity anode production at Aditya Aluminium for premium grade metal production, and also successfully executed second FTA erection project brownfield at Aditya Baking Furnace. So he is currently based at the Renukut smelter of the Hindalco Industries Limited. So thank you, sir, for joining us for today's session. It's over to you. You can share your slides. You can start the presentation. Thank you.
Thank you. Thank you, Amulya.
Thanks.
So good evening, everyone. So I really thank you to the organizing team for this kind of learning session you have planned and organized. And I think this one is the 8th lecture series. So
Yes, sir. Yes, sir.
So thank you and congratulations for successfully completing till 7th
Thank you, sir.
sessions.
Thank you, sir.
And let us start. I will share my screen and we'll go to the topic. Just a minute. I am not able to share. Can you check? Post disabled participant screen sharing.
Okay, sir. Okay, sir. You can try now, sir.
Yes. Yes, it is now. Okay.
It's now visible, sir. You can put it in full screen mode. Yes, yes, sir.
Okay.
Yes, sir.
So once again, good evening, everyone, to all the participants and listeners. So I will discuss and present on this topic, that is the productivity, quality and safety enhancement through digitalization and data analysis in aluminum smelter. So as I work in Hindalco Industries Limited, so I will share some of the case studies which we have implemented at our smelter, and we are in the way of this Industry 4.0 journey. So this I will cover in this presentation. So before starting, let us first understand about aluminum smelter. So what is an aluminum smelter? As we know, aluminum, this is it's one of the metal which is having its presence in all the materials in our day-to-day life. That is, if you see in transport sector, it is around 41% transport is being carried out through using aluminum. And packaging industry, 20% metal, aluminum is used in 20% as packaging industry. Similarly, other sectors, construction field, electrical, consumer durables. So aluminum has its significant presence in all the sectors, and we all are using aluminum in our day-to-day life, starting from the very beginning, the medicine, the aluminum foil used for the food, to the transport we are using. And the journey of aluminum, how it starts. The journey aluminum starts from the bauxite. Bauxite as its the primary ore. It started through bauxite mining. Then bauxite undergoes a Bayer's process, which produce alumina powder. Then subsequently, this alumina is treated in electrolytically treated at high temperature using some other raw materials, and that process is called aluminum smelting. So there, the product is the aluminum liquid aluminum, and further this liquid aluminum metal is customized to various products as per the requirement through downstream applications. So this is the life cycle of aluminum. And if we compare and go to the past to know the history of aluminum, so it is first invented or created in the year 1854 through some alternate method, that is aluminum chloride and sodium, using sodium. So after that, the main journey or transformation happens when the Hall Herald process come into the picture in the year 1886. So from that, the process lies the Hall Herald process, but the technology upgradation goes time with time. Like initially the anodes were Soderberg anodes, then later it converted to pre-baked anodes, and the amperage has increased with respect to the time. So this is the brief history of aluminum. And this is the basic concept of aluminum electrolysis process, how the production is converted from the electrical energy. So I can this 1 minute. Okay. So the only I can say that using 1 kiloampere of electrical energy, we can get will get 8 kg, 8.05 kg of aluminum per day. So the principal reaction which happens in the electrolysis process, that is Al2O3 plus carbon, gives rise to aluminum and 3 CO2. And if you see what are the various inputs required for the production of 1 ton of aluminum, then we found that from around 5 to 6 ton of bauxite gives the alumina, that is something around 1.92 ton of alumina, and 410 kg of carbon, 18 kg of aluminum chloride, 2 kg of cryolite, and using some electrical energy, that is something around 1300 500 kilowatt hour. This all cumulatively gives 1 ton of aluminum, along with some hazardous or non-hazardous gaseous byproducts, that is CO2, CO, HF, and CF4. So this is the raw material what is required for the production of aluminum. And this is brief process flow, as I have discussed in past slides also. Aluminum, this electrolysis process happens in the electrolytic cell, that is the pot. For the pot, the inputs are, one is DC power, electricity, another is alumina, and third one is the anode. So anode is the one of the consumables, as we have seen in the previous slide, that around 410 kg of anode is getting consumed for the production of 1 ton of aluminum. So anode is getting consumed regularly. So every smelter, what happens, they produce anode by themselves for their regular use. So for anode, the production starts using the raw metal CP coke, calcined petroleum coke, and pitch. So using these two raw metals, first process is the anode production. So anode produced, and that anode is taken to the pot room for the electrolysis process. So during electrolysis process, this anode is getting consumed and reacted with the oxygen, with the Al2O3, oxygen from Al2O3, and consumed periodically. So this, when the metal is produced, aluminum metal is produced, that aluminum is taken out from the pot cell, and further it was going to the cast house. Cast house means there this liquid metal converted to solid form. So this is brief introduction, brief process flow of the aluminum smelter. And during my discussion, I have told that in aluminum smelter there are mostly 3 production units that are the important. That is anode plant, second is the pot room, and third is the cast house. So this is the schematic drawing of a pot. The pot looks like this, where the pot cell is, the bottom is the pot cell, and in the pot cell anodes are placed. Anodes are placed in 2 parallel lines, and the bottom bed is lined with cathode block with a refractory lining and ramming paste. And here the electrolyte, the molten bath cryolite, is used as well as the liquid metal is lies on the bottom and cryolite bath lies on the top of the metal. And the center is the feeding the alumina hopper, where the alumina gets into the electrolyte with a defined feeding rate. So this is the schematic diagram of a pot cell. And in pot, the key process that are taking place, that is alumina feeding, anode changing, and metal tapping. Anode changing because anode is getting consumed, so it needs to be replaced with after a certain time. On an average, it is something around 72 shifts to 68 shifts to 72 shifts. The anodes are getting changed. And every day the metals is getting tapped out, as the calculation says the amperage, based on the amperage per day there is some production. So as higher the amperage, the higher will be the production, and accordingly the tapping capacity will be more. So based on the production and production capacity and amperage, the tapping schedule is planned and metal is tapped out from the pot cell. And this is the process flow chart of the carbon plant, where the carbon anodes are produced. In carbon plant, this raw metal, this calcined petroleum coke and other dry aggregates that are passed passed through the crossing circuit. And after crossing circuit, these dry aggregates are getting preheated. After preheating, these are mixed with pitch, coal tar pitch. It is the dry aggregates mixed with coal tar pitch, and to prepare a homogeneous mixer paste. That paste is compacted through a vibro compactor, a mold, a rectangular shape, where the paste is dumped and it vibrated for a defined time of 50 to 60 seconds. And after that, the anode is prepared. And this anode is called green anode. Green anode because this is freshly prepared using the fresh raw materials, that is CP coke and pitch. So it is green anode. This green anode is not suitable for using in pot room in the electrolytic cell, because this anode, the pitch is not solidified properly, because pitch have a softening point of 118 to 120 degrees centigrade. So when it will be used in pot in the temperature of 600 to 900 degree temperature, at that time this pitch will not sustain at that. This green anode will not sustain that atmosphere. So to enhance this mechanical and thermal and chemical property of green anodes, the next step is anode baking. So anode baking, what happens? This is one kind of heat treatment process where this green anode is heat treated at a controlled atmosphere at the temperature of 1100 degree temperature, so that the anode's electrical conductivity, thermal stability can be improved. So after baking, there will be no physical changes in anode. Anode will be looks like the same. Dimensionally, there is some shrinkage in volume, and chemically it will becomes less reactive. So this baked anode further goes to rodding shop. Rodding shop, what happens? As we have seen that the anode is hanged inside the pot cell. So there we need to put some hanger or some solid bar that can be act as a holding method for the anodes, because anode is a rectangular block. So in rodding shop, the carbon anode is fixed with a rod, the metallic rod, with the help of cast iron. So this is rodding shop. So in rodding shop, this rodded anode, when it is prepared, then this rodded anode goes to pot room. The final anode looks like this. In the last picture, the anodes looks like this. The top part, the top rectangular part, that is looks the anode rod, and the bottom part, that is the carbon anode. So this goes to the pot room for uses. And when the molten metal is prepared and tapped out from the pot cell, then it sent to the cast house. The next part is the cast house. Cast house, what happens? The molten metal which is tapped out, that is again again put inside a furnace, that melting and holding furnace, to maintain the melting temperature of aluminum. Then it further taken to the solidification process through ingot or so ingot as per the desired size. As we know this, the basic process and operational areas of anode aluminum smelter. So these are some of the performance indicators which judge the performance of aluminum smelter. So these are the productivity, the production of aluminum, the production of anodes are the key performance indicators. for quality term point of view, the quality of metal and the product variety, how the product rejections. So all these are the quality parameter. Cost, in terms of cost, the cost of production, the specific consumption of the raw materials, and for delivery, the on-time delivery to the product to the final customer, the customer satisfaction index. So all these are delivery. And for the safety, because smelter is a manual intensive process, low, so many manpower, people are working with the equipments at a high temperature zone. So zero harm is the safety performance parameter, and moral, employee satisfaction and skill enhancement are the moral component of the KPI. So these are the KPI which are important for aluminum smelter, and these KPIs are prone to change with some adverse atmosphere, like when there is summer season or the season external effects are there, or some global crises are there. So these KPIs are getting changed. So this here comes to the data driven decision making or the digital integration. This requirement comes to this to address all kind of unforeseen situations or unforeseen challenges. So this is the requirement of decision making through digital initiatives, or next generation ready smelter can be prepared through digital initiatives. So this is the requirement comes, like for this kind of process complexity, the faster decision making, productivity boost up, quality consistency, and enhanced safety. So to address all these challenges, data driven decision making is very much important. And if we are not able to take decisions within a fraction of time, or within certain based on the data, then smelters cannot be that much competitive with the global smelters. So to make this smelter plant as a plant of the future, we have at Hindalco smelter, we have taken certain various kind of digital initiatives, and that I will explain in the coming slides. So now let us understand about Industry 4.0. What is this? So this is one type of industrial revolution, which we call as the fourth industrial revolution. So the first started in the year 1784. That is basically the mechanization and steam power plants, weaving looms. So this is the first industrial revolution. And the second industrial revolution that started in the year 1870, that is basically focused on the mass production, on the assembly lines, and how best the electrical energy can be used. So this is the second industrial revolution. And in the third part, 1969, the Industry Revolution 3.0, that is basically the automation and use of electronics for the manufacturing. And now this is the Industry 4.0 is going on, that is cyber physical systems, Internet of Things, networks, and automation, digitization. All these things are coming under this 4.0. So this is basically the core technology, the cyber physical systems, IoT, AI-enabled real-time data exchange, smart decision making. So these kind of core technologies are this part of this Industry 4.0. which will support to prepare the our factories in a smart factory means where the productivity and responsiveness is dynamic, and the impact of its impact on manufacturing is it makes the production, the quality of product is to global competitive. So this is a brief elaboration about digitization, what is digitalization, and what is digital transformation. So digitization, basically it is the process that is making the information available and accessible in a digital format. Because what happens when the earlier plants, the data are captured in a manual format, manual logbooks, manual check sheets. So to convert that manual system to a digital format, that is basically a digitization initiative which have been taken in the early stage. And to further add on that, the digitalization initiatives have been taken. That is the converting this to a automated version for a more simplified way to capture the data automatically. First step, manual to digital format, then digital format should be automatical way. And in the digital transformation, this is in the line of the business need. business applications, various kind of business applications, the various kind of digitalized applications that can take the decision on the basis of on the benefit of the business. So this is the digital transformation. And in this industry 4.0, we can see that the basic principles are like interoperability. Interoperability means the seamless communication between the various equipments, because in smelter or in pot room, in carbon, there are huge number of equipments, and the communication between the equipments is very much important. So the type of communication, the faster communication, faster response between one equipment to other equipment, this interoperability is very much critical. And based on this interoperability, this industry 4.0 works. And another advantage of this industry 4.0 is to give the human interventions with proper justification. The human intervention is based on the certain guided rules, based on which is driven by the performance of the equipment as well as the data which is captured through the equipment. So these are the certain principles of how the industry 4.0 works in manufacturing sector. And what are the technology behind this industry 4.0? So the core technologies that is lying behind this smart manufacturing are IoT, Internet of Things, artificial intelligence and machine learning, robotics and automation, cloud computing, and big data analytics. So using these technologies, this industry 4.0 drives on in manufacturing sectors. And this is on the terms of various interconnected systems, digital twins, predictive maintenance, and sustainability and efficiency. Now, let us see about the various industrial applications and benefits. So, if we use this industry 4.0 or will drive this industrialization, digitalization initiatives, so this will help in real-time monitoring and control, AI-driven supply chain optimization, end-to-end digital integrations. So these are the benefits which we will get as a operating entity. So this is one just for a minute, 1 minute pause. So this is some interesting facts about aluminium. Because as we are covering this topic for a long time, so this is just a quick short information gathering session. So aluminium is the most abundant metal in Earth's crust. Almost 8% of the Earth's crust is aluminium. In 1800, aluminium was more valuable than gold due to its rarity. The Hall-Herold process, discovered in 1886, is still used in aluminum production today. There is no alternate methodology for this. Aluminium conducts electricity almost as well as copper, but 3 times lighter. And aluminum can be infinitely recycled without losing quality, and the recycling saves almost 95% of the energy. And the aluminum used to be more valuable than gold once upon a time. So now let us discuss on the used cases of Hindalco Industries Limited. So I will take you through the cases. So first, let us why this concept came and what are our focus areas we have chosen. So the focus areas. The focus areas we have selected for this digitalization initiatives are, that is first is the building. एक बार म्यूट कर लेंगे. क्रिकेट फुटबॉल बैडमिंटन तो छाड़ू आर भॉलीबॉल. So the focus যদি এই বাকি যে গেস্ট ফ্যাকাল্টি গুড়া সেমানଙ୍କର ଆପଣଙ୍କ ସହିତ କାର ଭଲ
हाँ ଆପଣଙ୍କ କାହା ସହିତ ମିଶିକି ସେଠି ନାହିଁ ଫୋରମ ବିଟ୍ ଟା କିଏ କହିଲେ ଓହୋ ହୋ 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 ଫୋରମ ବିଟ୍ କୋଉ ବ୍ରାଞ୍ଚ କେମିଷ୍ଟ୍ରି ନା ବାଧ୍ୟ ନାହିଁ ଗେଷ୍ଟ କରିକି ଆଇବେ ନା ଆପଣ କହିଦେବେ ନା ପ୍ରିନ୍ସିପାଲ ଅର୍ଡର କରିଛି ନ ଅର୍ଡର କରୁଛି ଆମକୁ ବି ଭେଦବ ମୁଁ ତ ରଖିବି ଶଳା ଶଳା ରୁହନ୍ତୁ ଟିକେ ହ୍ୟାଲୋ ମ୍ୟାଡାମ
Okay, so let us continue again. So the focus areas we have drilled out like first, let us build a robust digital infrastructure so that will help for the data management platform as well as the strengthening our IT/OT connectivity. Second focus area was the investment in digital manufacturing technology to improve the efficiency and quality. Third, focus on asset reliability, energy optimization, and safety. Fourth is utilization of AI and analytics to unlock actionable insights and drive the innovation. Fifth part was the collaborate with governments and startups to foster growth and digitalization. So keeping all these focus areas, we have prepared our vision for the plant of the future. So for this vision of plant of the future, we have categorized in these 5 pillars. Base is the foundation layer, then the technology stack, then process and system layer, then decision layer, and value delivery. So on every layer, we have started working on the various aspects. Like in foundation layer, IT/OT management, data management, digital workforce, digital mindset. For technology stack, we procured and get the consultants, get the purchased certain software technology stacks from various developers. Then process and system layer, we connected plant automation, asset performance, safe, secure place, sustainable manufacturing process. So this we work, and the decision layer and value delivery is one kind of the result which we are working upon. So now let us start one by one. First part was the strengthening our foundation layer. So foundation layer was the data management system. So here we worked upon OSI one system that is supplied by Aviva Pi solution. Nowadays we have implementing across our smelter and power plant operations. So this is basically one integration of OT and IT networks with some additional firewall protection. So this basically why required, because if you see in smelter or power plant, more number of data from various sources, and all those various sources are kept as a independent entity. So to read one data in relation with other data is very difficult. And if one person wants to get a complete information, he is very difficult to get this information, because one is data source is different, number of data sources are there, and number of data is also large number of data are there, and real-time monitoring and its linkage to the result is quite difficult. So this dashboard, I can say this is one dashboard which is prepared keeping all the relevant informations in real-time monitoring. So here the data are captured from various sources, and every minute, every second data is getting accumulated in the single page, and whatever necessary data is required, those are transformed to the desirable visuals like graphical or graphical trends, and which performance is as going as per the target or going beyond the target or not performing. So all these things can be visible in this one single window. So this is one kind of solution we have installed in our smelter. So this helps in real-time data availability for quick decision making, and it is giving a easier way for plants to review operational parameters anytime from anywhere. And the plant itself, we are able to compare, because similar data or similar visualization is available for all the smelters, because Hindalco operating at 4 different smelters. So all these smelters performance can be visualized at a single page, and it can be compared one to one with respect to the other on the scale, on the basis of the similar parameters. So this plant comparison is quite easier, and data accuracy and reliability also improved. So this is the benefit of this activity which we have taken. And another example is for the safety enhancement, because safety is one of the major KPI, as we discussed earlier. So to enhance and improve the safety, we have installed this thermal imaging cameras, because in smelter, as it is high temperature zone, so many areas are high temperature zones, and high temperature zones are very prone to fire incidents. So to capture these fire incidents before happening any major fire incident, we have installed these thermal imaging cameras, because since last 5-6 years, in the year 2019, there are 2-3 major fire incidents happened inside our plant. So this prompted us to go for this kind of automatic solution, so that before the incident of any fire, we can trace that there may be some possibility of fire because of the high temperature. Unexpected temperature rise happens, so there may be some chances of fire. So it will automatically give some alarm that this equipment is getting overheated, or there is some spark is generated. So the corrective actions can be taken automatically. Automatically means it will give command to the fire extinguishing and fire suppressing systems, so that it will getting activated. So this kind of automated system we have installed for the safety enhancement. And this is another example of this of safety enhancement initiatives. As I have told, that when the aluminum metal is tapped out from the pot, it is taken to the cast house through ladles. Ladle is carrying capacity of almost 8 to 10 metric ton. So this ladle is a steel vessel. Inside is lined with refractory castable material. So chances are there this castable getting wear out, and some leakage will happen. So to avoid this kind of unforeseen situations, because if that happens, then the metal is getting aluminum molten metal getting directly contact to the steel cell of the ladle, and chances of the welding joint failure or leakage of the ladles. So to avoid this, around continuous monitoring of the temperature profile across the ladle has been installed. Means one station is prepared, and there in the first picture you can see at this point there are 4 to 5 number of cameras. Infrared cameras are installed at different angles, so that it can take the hot zone and temperature thermal imaging. It can take the thermal image from different angles, and it can give a insight that yes, the temperature is in the normal range, and it is safe to use. So this kind of system we have developed, and its monitoring is on the basis of real-time monitoring. And real-time, it gives the signal that if any deviation happens and the temperature is not within the normal allowable range, then it gives the signal so that the corrective action can be taken. So this is another safety enhancement initiatives we have taken. Another advancement recently we have developed, or we have installed in our industrial vehicles, because in our smelter there are number of industrial vehicles which are taking the metals from one place to another place. Like the anode are getting transferred from anode plant to pot room. The molten metal is transferred from pot room to cast house. The raw metal are procured from outside, that is also coming from some heavy vehicles. So all these kind of vehicle movements and vehicle utilization, vehicle idle time, so this needs to be monitored, because when the number of vehicles are more, then the chances of its annual operation will be more. So to avoid this, we have installed this kind of smart fleet management system in the vehicles. So this is basically what happens, the GPS monitoring system with some enhanced oil consumption and some data interference, means how much time it is getting idle time, how much time it is not moving, or the vehicle is standing at it's not following its normal route, it is going some other routes. So this kind of features we are installed here, and we are monitoring regularly, so that this is giving some positive insights in terms of the real monitoring, real time vehicle tracking, the driver accountability, whether driver is keeping the vehicle in the wrong place and the parking the vehicle in the wrong designated place. So these kind of abnormal behaviors and unsafe act of the persons we are tracing, and based on that we are working on those particular defaulters. And as a result of this also, we are getting some financial benefit, that is the fuel consumption saving. Because what happens earlier, what happens, the driver many times keeping the vehicle on roadside and keeping the switch on, engine on. So this kind of phenomena are happening. But now this is a completely stopped. So this also we are getting benefit. Now coming to the some initiative about the quality improvements. First is the quality improvement. This is about the rejection minimization. Rejection minimization means the anode which is produced, if that is not inspected properly, because this anode, this is about green anode and baked anode. Green anode produced in the green anode plant and baked anode produced in the baking furnace. So these anodes, if it is not inspected properly, there are some rejection criteria defined. If anodes are not monitored or not rejected at respective green anode plant or respective baking furnace, then what happens? This anodes is supposed to go to pot room for use, because if it is not rejected means it is good anode, and good as a good anode it will go to pot room, and when it is used in pot room it will not perform as desired, because it have some rejection criteria, rejection parameters, but it have been passed out. So to avoid this, initially what happens, we deployed manual workmen for the inspection of these anodes, because and as we know, manual intervention is not 100% error free. So there are some chances that some anodes are passed out or some anodes are not inspected properly. So we thought and developed this anode inspection mechanism through visual camera using AI technology. So here what happens, we installed some cameras at different angles at green anode plant as well as baking furnace. So this camera, what happens, this camera reads the surface of the anodes, the physical appearance of the anodes, because this is the physical rejection criteria. So the camera read read the various kind of activities are supposed to happen in anodes, and based on that it memorize the nature of defects, and when it gets any signal of this kind of defects, then it automatically give alarm that yes, this anode is rejected. And this kind of pictures, it is continuously appearing on the screen. The control room operator or in charge who is there in the control room, he can visualize that all the different angles of anode, it is taking the pictures, and based on the predefined criteria, it gives a signal that yes, this anode is rejected or this anode is good. So like this anode number, it is showing that okay, not okay, not okay. And if it is showing not okay means there are some abnormality present. Then what happens further, he will check the different angle of the pictures and visualize that what kind of rejection criteria, like chunk out or oxidized surface, or the stop hole is damaged, or there is some segregation on the surface, or the crack is present, or it is good anode. So this kind of signals he will check, and he will confirm that yes, this is reject or this will be it will be good anodes. And apart from this rejection and avoiding the manual intervention, this dashboard or this software helps to analyze the data. Analyze data means it captures all the data's physical appearance history, and based on that, how much is rejected on every shift, on what category it is rejected, all these data are captured automatically. So this is also helping to analyze and helps the process team or the quality person to work upon on the particular aspects. If the rejection is higher on a specific region, then he will work upon that. So this is helping in quality improvement also. One part, the rejection is reduced or controlled because the defect detection accuracy is increased. The rejection rate is reduced because the inspection is robust, means the rejection will be automatically controlled because the action will be taken immediately. If there is some abnormality happens and it is continuously appearing, then the plant people are requested to work upon and take the corrective action. And the inspection time also reduced because earlier what happens, the manual people, one or two people are standing there and checking that, and for one anode they take some n number of times, but this automatically it will stay at this station. It will happen, the inspection is takes hardly 1 to 2, less than 1 minute. And the rework cost also reduced because if the rejection will be increased, the reprocessing cost will more. As the rejection is reduced, so rework cost is also reduced, and the safety risk during the scrap or reject material handling also eliminated. Because the earlier what happens, the rejections which are rejected, that needs again shifted to another place. From that place, it again reprocessed. So there are some multiple handlings through forklifts or through some material handling vehicles. So that also eliminated because the more the metal undesirable handlings are there, the more safety risks are there. So that once we eliminated the handling of the unnecessary handling of the materials, so we eliminated the safety risk. So two things we have covered. One is the foundation layer, about the foundation layer strengthening through this Aviva Pi software dashboard. And second, safety enhancement, how we have installed the various initiatives for the safety enhancement. So now coming to the quality enhancement, how we improve the product quality and process quality. So this is one example I will explain. This is a baking furnace. This picture is first picture and second picture. This is about anode baking furnace. So anode baking furnace looks like this. It is a vertically down chamber where the anodes are packed, and anodes are indirectly heated to 1100 degrees centigrade. Indirectly heated means anodes are not directly getting contact of the heat flame. So anodes are indirectly heated, and the criticality of this process lies because you cannot increase the control the increase of anode temperature. You cannot raise the temperature as you wish because it is indirectly heating. So to control this anode temperature, we need to work upon the flue gas temperature and the fuel we use. So this anode temperature have a significant impact on the anode quality because anode is not baked properly, means the quality is not as per the requirement. Quality means the electrical resistivity not improved up to the match, up to the desired target. The baking level, the crystallization level of crystallization also not improved. So this kind of abnormality in terms of quality happens. So we observed that our baked anode temperature was not going up to the desired set point, that is 1100 degrees centigrade, and this reflected in the terms of the anode quality. The anode electrical resistivity was not as desired. The crystallization size also not desired as per the desired parameter. So we taken help of one of our data scientist. In Hindalco, we are developing as data scientists, so many engineers to data scientists who are working with the operation team for various kind of data or digital projects. So this is one project we have taken through using data scientists' help. So in the first phase, we prepared the data sets, various data required for this study. We prepared the data set. We collected the relevant data of all anodes baked and sample tested in the past 2 years. Then the section wise, the pit wise data mapping we did. Then in phase 2, we converted the analysis, which are the critical zones. We do the analysis for the critical zones, why the anode quality is is poor in the particular zones. So that we identified, and we tried to relate the various impacting factors on the anode temperature. Then in third phase, we studied on the critical sections and why these critical sections are similar, or is there any similar nature in these critical zones, that we studied. Then finally, we derived some solution and we tried in some of the sections, and then we further validated with the results. So this kind of study we did through the machine learning and data scientist person. So we in the first picture you see that we have identified the critical pits where the properties are poor, and subsequently where the anode temperature was less. And that pattern we found that have a similar pattern. Some of the pits are repeatedly showing the less temperature. In the last this green color zone, you see that some of the pits are repeatedly green, means there are no improvement in the last three cycles. So this kind of plotting we did, and we further correlated this with the performance of the furnace furnace construction, because this furnace is made up of refractory bricks, high aluminum refractory bricks. So this high aluminum bricks performance deteriorated with time. So whether it is because of the high aluminum bricks performance, or is there any other parameters affecting this temperature profile, because temperature is not achieving even after 3 cycles. 3 cycles means it is around 3 months. So in 3 months there are no change, and some of the sections are repeatedly underperforming. So this data gives some good insight that where we need to work. And after working on those critical sections, we have taken some calculated action plan, like we replaced the flue walls, we increased the temperature of particular those damaged flue walls or damaged sections, we increase the final temperature. So after taking some corrective actions for those critical sections, we found that yes, there are some changes happening in the performance of the anode. And the result part, we found that there are some significant improvement in these results. The baking level is also improved. The anode temperature has improved. Earlier, the temperature was in the zone the 70%. Now that converted to 82%. And the baked anode in the month-wise, the baking level also started. The lower population means the lower part is non-desirable. So the lower quality, the poor quality also started decreasing. Earlier it was gone up to 10%. Now it is coming 0%. So this kind of improvements we observed after doing this improvement. And also we analyzed another thing, because once we are able to capture the large number of data, then we have a scope to read those data. So this is one simple data. This was there itself, but we are not able to find this data and read in a structured way, because for the injection of the fuel, there are some injection parameters are there. So this much data was there. Almost every second the data is captured. And from there, we found that, yes, some flue walls are behaving differently. The red zones are taking more fuel. More fuel means the temperature is low at that point. So it is the oil demand is increased, because oil is used to get the heat. So temperature is less. So why temperature is less? Because there are some other factors affecting at that particular flue walls. So this we worked upon, and after that you see the second picture, there are almost eliminated this kind of abnormal behaviors. So there are almost smooth oil flow and oil injection across the flue walls. And if you see in the first picture, the oil injection was 1,43,266 per milliseconds, and in second it is for 1,25,000 milliseconds. So from this time means time is reduced, so oil injection also reduced. So this way, along with the quality improvement, the oil consumption, the specific raw material consumption also reduced. And this is helping into maintain the product quality, the cost of production within the target range. And this is another quality improvement project we have taken in our cast house. In cast house, the ladles which are coming from the pot room, that needs to be categorized on the basis of its quality, because in pot room there are 360 number of pots, and all pots are not having the same quality of metal. somewhere it is the desired the iron and silicon content, which based on the iron and silicon content. So it was categorized as P1020 or P610 or P506, P406. So all pots are different. So to have a good a standard product, we need same type of metal from the pots. So for that, a subtle planning, subtle software we developed in-house. In-house we developed this logic, and this captures the data from the laboratory analysis and make a plan of the selected pots. So it automatically give pop-ups that these 3 or these 4 pots can be taken together, so that the metal will be tapped out and sent to the cast house for the effective production of the ingots. Because what happens if 2 different kind of metal is going for the same batch, then the product quality will be not as desired. So to avoid this opti-subtle mechanism we developed, and we are following in the smelter. And this is a good core, good data bonding or data interpretation between cast house and pot room. And after casting of the ingots and so ingots, its nomenclature also we developed. So this is a completely ERP based metal tracking system we developed. So this is complete linkage between the pot room. Once the pot room sample goes to lab, the pot room sample goes to lab for analysis, and from lab it gives the signal to pot room that this is the laboratory, this is the result, and based on that it goes to cast house. Cast house, after casting, the finished product is marked including all these 3 numbers. The chemical composition, it appears on the tag, the process data, what was the process data that time, the temperature that time, the what is the alloy composition, and the production data means the day of production, the quantity of production, and its quality, and when it was handed over to the logistics or the dispatch to customer. So all these data are captured in the single barcode. So if any we scan this code, from which pot this metal came, what was its parameters, key parameters, and when it was casted in cast house. So all these things come in a one single barcode, and this helped to further to share with our customers. So this is good initiative taken by our internal teams. Now this is about productivity enhancement. How we enhance our production or the productivity of plant through these digital initiatives. So this is basically one kind of process parameter and process equipment performance monitoring we developed in ourselves. This is about green anode plant. In green anode plant, there are so many parameters that is controlling the anode quality. So to have a proper track on these parameters and timely monitoring of this real-time monitoring of these parameters helped us to improve the production numbers as well as product quality. Because what happens, most of the time the equipment performance is not in a steady manner. Like the key equipments in the green anode plant are the ball mills, the belt conveyors, and the crusher units. So this is not performing in a steady manner. There are some variations. So on which variation, on what times it is on the positive variation, what time it is negative variation, and how its behavior to the production quality, product quality. So this linkage we found, and based on that, it gives the indication that now the variation is on the negative side. So it may have some impact on the product quality. So based on that alarm and pop-up, we take some action, corrective action on the upstream side. We change the raw metal, or we stop the plant, take some corrective actions if it is beyond the limit, beyond the control. So this kind of help we are getting through this real-time monitoring as well as this process parameter monitoring. So this helped in improvement of the productivity of anode plant. And another example is about productivity enhancement is the online condition monitoring of the critical equipments. Because in smelter there are several equipments which are critical in nature, like compressor or some various static equipments like ball mills, ID fans, autogenous crushing mills, crusher units. So these are very much critical for the continual operation of the smelter. So to maintain the critical equipments by predictive monitoring system, we have used this artificial intelligence system to identify and detect any kind of abnormalities that may lead to the breakdowns. So this helped in increasing the plant reliability, and this gives signal or give direction to for the proactive maintenance of the particular equipment. So here that on the three four parts work, like sensor layer, communication layer, processing layer, visualization, and alerting. So sensor layer means we installed some real-time vibration monitoring and temperature sensor. If it is not there in the earlier equipment, then how this system or the sensor is getting communicated to the network, the PLC system or the SCADA system, how it will be connected or it will communicate there, and how the data is data reading. This data is as per the target, or it is going the based on certain reference parameters, how this data is readable, or how data is converting to the actionable points. So this is the processing layer. This we worked upon there. And lastly, visualization and alerting. We have installed this in various desktops of the shift engineers, and we have given tabs to the maintenance people so that they can access from their mobile itself, or from this specific tab. So they at anywhere inside the plant, he can check the equipment, and he can identify the equipment for key performance, like the vibrations, the temperature of the bearings, the oil levels. So these kind of things he can check and detect the abnormalities. So one example here, this is about one pump equipment, one shot blast machine in rodding shop. So there we have installed this kind of network, and this first we install the required sensors, then that sensor connectivity to the master network. And these kind of visuals we observe in the graph, like the bearing defects, what are the factors that are going out of the control, whether the alignment is disturbed or not, the the trend of last 5 hours, or from what time this is getting worse. So this kind of informations we are getting. And this type of dashboard also present, that is also helpful for the maintenance engineer to analyze the data, like overall plant. I think if the person is looking after 10 to 20 equipments, so he can at any point of time, he can find out, yes, how many equipments are running critical, or it is running excellent way. So he have a good insights at any time on his mobile, and when there is some abnormality happens, or any deviation occurs, then automatically he is getting some pop-up, and automatically get some messaging to his mobile number, to his mail ID. And further, if it is going beyond the limit, it is further escalated to the next level also. So these kind of features we have installed and worked on this. All the equipments of the smelter, we have installed this kind of preventive maintenance module. So these are some dashboard screenshots. And apart from this, there are certain other initiatives we have taken in smelter, like digital dashboards and real-time monitoring and tracking through. One is first part, that is Aviva Buy's platform, and second, this is another platform by in-house team in Power BI and Oracle OPEX platform. So these kind of initiatives are taken by our in-house team. And this help for the other activities, like the inventory management, the breakdown management, the raw material sourcing plan, how much time it is getting takes from a procurement plan, requisition to purchase of the item. So all these things are monitored through these digital dashboards. And we have developed some AR/VR based training modules, so that is helping helping the new joiners, and helping for the new joiners, as well as the critical equipment breakdowns. Like if some breakdown happens once in a 10 years, so that how the solution methods, the maintenance practices is captured through these training modules, and that will help to the next generation people in future. And another model is we have developed prediction model for anode quality, pot life, pot abnormality. So for this also we have developed, so a real-time monitoring on the pot performance and pot life, how the life of the pot is going to be happen in coming years, which what is going to be critical in next 1 month, 2 months. So this kind of prediction models also we have developed, and that is also going working well and helping the boardroom as well as carbon plant team. So let us take another 1 minute pause and just learn another few things about aluminium. So this is some of the interesting fact about aluminium. So aluminium is lighter than you think. It is almost 1/3 weight of the steel. So it is very much perfect for airplanes and can bottles. So almost 80% of aircraft's body is made with aluminium alloys due to its strength and lightweight. And second is aluminum reflects 92% of visible light and 98% infrared heat used in insulation. So it is used in insulation and spacecraft. In kitchen, the aluminum foil is used because it is thinner than human hair. And aluminum has a high strength to weight ratio, so that force it's used in cars, buildings, and bridges. Then it is known as green metal because aluminum supports the sustainability in EVs and renewable energy. The solar panels and the EV battery enclosures, so those are made of this aluminum. So these are some facts about aluminum which help for its use. So as we know that there are so many benefits, so many positive impacts for this digitalization and this data-driven decisions, but still there are some challenges, and these challenges because the adoption cost is very high because as I say in one of the example that for the online condition monitoring of equipments. So there are so many equipments, what happens, the initial components are not as compatible for these digital initiatives. So we need to take some additional cost to install the instruments, install the monitoring devices, install the network devices. So this adoption cost is very high. So many times what happens, it is very challenging to get some approvals from management for these kind of projects, because these kind of projects uh, it is not immediately gives the result, because you monitor the when you monitor the equipment performance, you cannot predict that when the breakdown will happen and when it can give the indication. So the result or the benefit is after a long period we are getting. So management many times it takes a long time, or decision making at management is very critical. And second thing is the legacy system. Many old systems because are not designed for such kind of new industrial revolution. And the another threat is the cyber security risk is very high, because the more we are allowing on this kind of connectivity and accessibility to everyone at every places, like mobile at different network, plant desktop at different network. So when we are allowing this kind of access at different networks, so the risk of cyber security is very high. So this is also one of the barrier to, so that it is challenging how best we can mitigate this challenge. And the workforce who will deal with this kind of technology, this kind of digital unique advantages, they need their skills to be at that level. So the training of the employees, the acquainted of those kind of with this kind of tools and instruments is also one kind of time consuming as well as cost involvement. So this is also one of the barrier that is pose a challenge to these digitalization initiatives. And there are challenges, there are benefits, but still the development and progress in the next revolution is still it is going on, like industry 5.0. So in industry 5.0, this is basically human machine collaboration. It will focus on the collaboration between humans and machines to enhance the creativity as well as decision making manufacturing on a faster rate. And it will focus on the more advanced technology integration. It will focus on the sustainability and inclusivity. So these are the future of this industry revolution 5.0. So now coming to the conclusion and key takeaways. So in the conclusion, Industry 4.0, this integrates advanced technology to enhance manufacturing efficiency, flexibility, and sustainability in aluminum industries. And the challenges and adoption is high because challenges are there, but and adoption rate also high, because if any plant or any smelter is not adopting this kind of innovations, then he will be not in that much competitive in this challenging or in this uncertain world. And now the vision for Industry 5.0, many industries have already started across the globe. They have started the Industry 5.0 initiatives. And to address this, aluminum manufacturers should embrace digital transformation and collaborate across ecosystem to stay competitive. So this is the conclusion and takeaway from this session. So thank you for your attention. I hope I was able to explain about these initiatives of our smelter plant and basics about aluminum smelter operations and the requirement of this kind of digitalization initiatives in aluminum smelter. So this is about all about the presentation. So if any queries, you can ask or you can contact me.
Participants, if you have any queries, you can unmute yourself. That one question is there in chat box. How can blockchain technology contributes to traceability and quality assurance in aluminum production chains?
Yes, in blockchain we have started one of our gray area, that is the hazardous waste management. So there we have started because hazardous waste we are not supposed to dispose or dump to anywhere to anybody. So for this we have developed this blockchain. So this blockchain helped starting from our plant boundary to the disposal yard. This complete whole network we cover, and that helped in proper tracking and compliance of this hazardous material handling. So this is very good question. I forget about to cover this part. Yes, rightly said.
Any more questions from participants? Okay. Is any carbon credit saved with Industry 4.0?
Not directly carbon credit, but some benefits we are getting for using this kind of digital initiatives. We are getting some performance improvement, and that is helping in reducing our carbon footprint. Like this, the vehicle fleet management. So there, the vehicle movement we reduced and the fuel consumption we reduced. So that cumulatively helped in reducing the CO2 gas emission. That is first. The quality of product quality improvement. So there also we are getting the rework. We are eliminating, reducing the rework. So that is also helping. So this kind of the Industry 4.0 directly not giving the carbon credit, but it supports for the carbon credit in terms of reducing the greenhouse gas emissions.
Are you recovering any rare earth metals from red mud?
Yes, one of the refinery, they are presently working gallium recovery. So gallium recovery is underway. I think for that the desired unit will be desired equipment and desired setup will be installed in coming years. And presently red mud is completely reused. We are using it almost 100%. Like in some land filling and some other purposes, but the gallium extraction is underway. So it is proven and trial has been taken. Now the plant scale installation is under progress.
Any more questions from participants? Land filling again, deteriorating lands.
Yes, I have not much time. Otherwise, I can show in Renuput with using this red mud filling, they have created one golf course. Okay, so one scrap disposal yard, they filled this red mud, and after that, good soil they filled, and grass they made a good quality golf course. So yes, deteriorating the lands, but something can be done better.
Any more questions? Okay, sir, I think we don't have more questions. So actually you have given very clear picture of the how this aluminum smelter improvement product in terms of productivity, quality and safety improvement can be done. You have given the very clear picture using data analytics, and it's in progress. Whatever you have given, it's something is in terms of research you are doing there in your plant. You have given that idea also, and from the basics of the different parts of plant where you have using the data analytics and what improvement you are achieving in terms of quality, productivity that you have given. So it was very in-depth knowledge what is happening in the aluminum industry. Thank you very much,
Thank
sir,
you.
for coming and giving us so much knowledge about this industrial thing.
Yes, thank you everyone for actively listening this much time, and this at this time 7:30 to 9 o'clock. So thank you for this opportunity for me also to address.
Good evening. Good
Yes.
evening. Can we get your phone number so that I can have some discussion with you?
Yes, sure.
How could we? You cannot put it in there so that everybody gets that. How could we connect? Okay. Shall I will put my mail ID. Could you put there so that it will be easier?
Yes,
My
I
mail
will.
ID are putting.
Yes.
I think you got it.
Yes, I will update there.
We can have a talk.
Yes, sure.
It was nice presentation. Very nice. Very informative.
Thank you, sir.
Okay.
Okay. I think.
Thank you, sir.
Sure. Okay. Shall we leave? Conclude or?
Yes, sir. Yes, sir. So for
Thank you.
participants, we will again join tomorrow at 6 p.m. Okay. Thank you, sir.
Ma'am, one point. You have given
Yes.
that attendance of 80%. So those who have attended 4 days out of 5 days, it is 80% is over. So tomorrow we did not attend, isn't it?
Sir, last day is Saturday. 6 days
Oh, last day
program is there. Yes,
Okay.
yes.
Okay. Okay. No problem.
Okay, sir. Thank you, sir.
Thank you.